Look at the Earth. It's covered in water. But here's the crazy part. Only about 3% of it is actually fresh water. And most of that is locked up frozen in glaciers. It's what scientists call the blue planet paradox. We are quite literally floating in a giant ocean of water, yet struggling to find enough to drink. And the clock is ticking. Our global population is growing, agriculture is expanding, and climate change is making rainfall wildly unpredictable. As you can see, the line for water demand is shooting straight up, while our reliable supply is starting to crack under the pressure. We need a massive, drought-proof source of fresh water, fast. Enter desalination. The concept is beautifully simple. Take ocean water, run it through a specialized facility, strip away the salt, and pump out pure, fresh drinking water. It sounds like magic, but it is actually hardcore engineering. Historically, we did this using what I like to call the teapot approach, formerly known as thermal desalination. Just like boiling water on your stove, you heat the ocean water until it turns into steam, leaving all the heavy salt behind. Then you catch the steam, cool it down, and you've got pure distilled water. Simple, right? But as you can guess, boiling an ocean takes a massive amount of heat. That brings us to method 2, reverse osmosis. Think of this as the ultimate club bouncer. Instead of boiling the water, we use intense physical pressure to shove salt water through a microscopic membrane. The membrane's pores are so tiny that only the VIPs, the pure water molecules, can squeeze through. The salt and impurities? They get denied at the door. And humanity is doing this on a staggering scale. Right now, global desalination plants pump out roughly 68 gigaliters of fresh water every single day. To put that in perspective, that is a man-made river large enough to fill the Empire State Building to the brim dozens of times over. But there is a catch. Let's step into the ring and compare our heavyweights. Thermal desalination is an energy hog, using around 25.5 kilowatt-hours of energy per cubic meter of water. Reverse osmosis is much more efficient, dropping that number way down to between 3 and 6 kilowatt-hours. But even reverse osmosis requires a massive amount of electricity to create all that pressure. Because most of our global power grid still relies on fossil fuels, this creates an energy monster. Currently, global desalination is responsible for pumping around 76 million tons of carbon dioxide into the atmosphere every single year. We are burning fossil fuels to get water, which warms the planet, which creates droughts, which makes us need more water. It's a vicious cycle. And then there's the physical waste, the brine problem. For every 1 liter of fresh water we squeeze out, we are left with roughly 1.5 liters of super concentrated toxic brine. If we just dump this heavy, salty sludge back into the ocean, it sinks directly to the seafloor and suffocates marine life. So how do we fix it? The first step is decoupling our water supply from carbon. The future of desalination relies on 100% renewable energy. By building solar and wind farms directly alongside water plants, we can run these massive facilities without burning a single drop of oil or coal. Step 2 is better technology. Meet the graphene miracle. Graphene is a futuristic sheet of carbon that is just 1 atom thick. Scientists are using it to create next-generation filters. Because it's so incredibly thin, water flows through it 50 times faster than current membranes. This requires way less pressure, which drastically slashes the energy costs. Step 3 is solving the brine problem by turning trash into treasure. That toxic sludge we used to throw away is actually packed with highly valuable minerals. Engineers are developing ways to mine the brine for lithium to build our phone batteries, magnesium for building airplanes, and potassium for agricultural fertilizers. When you combine renewable energy, advanced filtration, and brine mining, you achieve the ultimate goal, the circular blue economy, featuring zero liquid discharge. In this system, every single drop of ocean water that enters the plant is converted into either fresh drinking water or valuable minerals, powered entirely by the sun and wind. Nothing goes to waste. If we can scale this up, we aren't just surviving. We are building true climate resilience. We can guarantee fresh water for billions of people, regardless of extreme droughts or changing weather patterns. We have the technology to literally create a world unthirsty. Thanks for exploring the future of water with me. If you found this mind-blowing, be sure to hit that like button, ring the bell, and subscribe so we can dive deeper into the science that is shaping our world. Catch you in the next one.